Hello students, today we are going to discuss few more examples to understand the concept of hybridization of different atoms in a molecule. So now we have to find out the hybridization of carbon atoms of this molecule. This molecule is anthracene molecule which is aromatic. So aromatic means it has C double bond C carbon bond, and these are conjugated and delocalized in the aromatic ring. So that indicates that all the carbon-carbon bonds present in the anthracene molecule has a double bond character. So all the double bond character means all the carbons are sp2 hybridized. So just for your information, when carbon has 4 sigma bonds, that is called sp3 hybridized. When carbon having one double bond and two single bond, so this carbon is sp2 hybridized. When carbon has triple bond and one single bond, so this carbon is sp. So here in the anthracene molecule, since all the carbon has double bond character, so these all carbons are sp2 hybridized. This molecule is caffeine molecule, and we have to find out the hybridization of nitrogen atom of this molecule. So if we look at the structure very carefully, we can see that nitrogen number 1, nitrogen number 2 and nitrogen number 3, their bonding pattern is almost same, but the bonding pattern of nitrogen number 4 is different. So now if we look at this 1, 2, 3 nitrogen, we can see this nitrogen is attached with a methyl. Then nitrogen number 1, that is attached with a carbonyl carbon and another carbonyl carbon. So this is nitrogen number 1. In nitrogen number 2, so it is attached with one methyl, another carbon and another carbonyl carbon. So this is nitrogen number 2. And nitrogen number 3, it is attached with methyl, another carbon and the carbon of the ring. So now you can see that all the 3 nitrogen having 3 sigma bond. So this nitrogen having 3 sigma bonds. And we know the nitrogen valence electrons of 5. So if I draw the valence electron like that, 1, 2, 3, 4, 5. So like each electrons are sharing with 3 different carbon. It is like that. So that means here we can see that this is one unpaired, this is one unpaired. So that means one lone pair electrons are present. So here nitrogen also having one lone pair. So that means now nitrogen having 4 hands. So that means 4 hands means this nitrogen is sp3 hybridized. So these all nitrogen, these nitrogens are sp3 hybridized. So let's write down here sp3 nitrogen, sp3, sp3. 3. Now look at the N4, nitrogen number 4. So the how it looks, how their bonding pattern, nitrogen, double bond, carbon, and then sigma bond with another carbon. So this is the 4, nitrogen number 4. And here one lone pair is present. So in this nitrogen having 1, 2. So 2 sigma bond. And how many lone pair? 1 lone pair. So here nitrogen having like a 3 hands. So that means this nitrogen are sp2 hybridized. So here 2 different types of nitrogens are present in the caffeine molecule. 3 are 1, 2, 3. Those 3 types, 3 nitrogens are sp3, and the nitrogen which we have written nitrogen 4, that is sp2 hybridized. So now this molecule is a 3-membered ring having double bond here. So just numbering 1, 2, 3. So there is a double bond between 2 and 3, and we have to find out the carbon 1, hybridization of this carbon 1. So if we look at the carbon 1, it has 1 sigma bond with hydrogen, another sigma bond with another hydrogen, and carbon and another carbon. So here the carbon number 1, it has 4 sigma bonds, no lone pair. So that means this carbon is sp3 hybridized. And just for your information, C2 and C3 carbon, there is a double bond between C2 and C3, and C2 carbon is attached with one methyl and one carbon, and C3 is also attached with one methyl and one carbon. So one carbon. So that means these are sp2. So this is sp3 carbon, this one sp2 carbon, this one sp2 carbon. Now in this molecule, we have to find out the hybridization of this oxygen atom. So now let's draw the bonding pattern of this oxygen atom. Oxygen is attached with one hydrogen atom by sigma bond, and it's attached with another carbon. So this is the carbon, and oxygen has 2 lone pair. So we know that oxygen valence electrons are 6, 2, 3, 4, 5, 6. So like carbon 1 electron shared with the oxygen 1 electron form a sigma bond. Now hydrogen 1 electron shared with the oxygen 1 electron form a sigma bond. So these two are the lone pair. So now in this molecule, oxygen has 2 sigma bonds, 2 sigma bonds, and oxygen has 2 lone pair. So that means it has, oxygen has 4 hand. So here the oxygen atom is sp3 hybridized. So this oxygen is sp3 hybridized. And if you look at the structure of hybridization of all the carbon atoms present in this molecule, it all has 4 sigma bonds. So all carbon atoms are sp3 hybridized. So all the carbon atoms in this molecule are sp3 hybridized. So hope you understand the concept of hybridization and how to determine the hybridization of different atoms in a molecule. Thank you. All the best.